I'm back. And so in our previous segment, we talked about how energy could be given to an atom and how the atom then could give off different kinds of energy. So in this segment, we want to narrow our discussion to what do electrons do in the atom when they're given energy. And so each of the floors of the apartment building have a certain amount of energy that goes with them. Now the amount of energy is determined by that very first formula, which says that it's going to be equal to negative 13.6 and then divided by n squared, where n is the floor of the apartment building. So the first floor of the apartment building would be n equals 1, the second floor would be n equals 2, and so forth. So that's the n that's in that formula. Now you might notice that EV thing. So the EV stands for electron volts, and it is a unit of energy. That's all that you need to know, is that the electron volt is a unit of energy. If you want to know exactly what the electron volt is, you can see there that down below it's equal to 1.6 times 10 to the negative 19th joules. So there, that's what the electron volt is. So let's try it. So for n equals 1, we would put n equals 1 into that formula. So 1 times 1 is 1, and 13.6 divided by 1 is 13.6. So you'll notice that the energy is negative 13.6 electron volts. Then when you go to n equals 2, you're going to plug the 2 into the formula. And so 2 times 2 is 4. So you're going to take 13.6 divided by 4, and then that gives you the energy of the second energy level. Now don't worry about the formula, okay? So I'm just showing you that's where they get those numbers from. That formula comes from quantum mechanics, so it's very difficult to actually explain how to derive that formula, but it comes from quantum mechanics. Now that still doesn't really help us too much, okay, because we now know that each floor has energy. So now the question is, how is that turned into light? Well, another thing that comes out of quantum mechanics is that the energy of light is proportional to its frequency. Do you remember that this thing here, okay, that stands for frequency. And the h is a fundamental constant of nature, Planck's constant, which you don't need to know. But the point is that if you have a certain energy, that will produce a certain frequency of light. So that when you go from, let's say that you're jumping from the second energy level down to the first energy level, what you do is you subtract the two energy levels, so the energy that goes with each energy level, you subtract those two numbers, and then you're going to set that equal to h times the frequency, and then solve it for the frequency, and that's the frequency of light that would be emitted by that jump. So you can see that an atom can absorb different kinds of light, and then when the electrons come back down, they emit different frequencies of light. So when energy is an atom and energy hits it, the electrons go up, they absorb the energy, and then when the electrons, they don't like it up here, because remember, they're always trying to go as low as possible. So when they return back down, they emit that particular frequency of light, and it all depends on the jump. Now I also want to point out, it has to be very, very precise. So let's say that you've got, here is an energy level, and here's an energy level, and then here's an energy level. And another thing, are you noticing that the ceilings are getting lower as you go up? So this is a very weird apartment building. So as you go up in it, you're having to scrunch down lower and lower in order to be able to live in those apartment buildings. Well, anyway, let's say that you've got an electron that's living here, and you give it enough energy that it precisely is able to jump to this energy level up here. That is permitted. You could also give an electron enough energy so it could jump to right here. That's okay. But what about if you gave the energy to an electron and it only had enough energy to jump to right there? No can do. So that electron wouldn't even jump. It wouldn't do anything. It would just sit there. So that an electron must be given precisely the right amount of energy so that it could either jump to here or up to here or whatever. You can't jump up to halfway. You can't jump 3/4 of the way. You can't jump 99% of the way. It has to be precisely one of those energy levels. So if, let's say that light is coming in with a certain energy and it's going to hit that electron. Well, if the light has the right energy, the right frequency, it will jump. But if it's the wrong frequency, it just goes right through the atom and nothing happens. So you can think of this as like stairs. So let's say that you've got some stairs that are 8 inches tall, and then you go to raise your foot and you raise your foot 6 inches. What's going to happen? You're going to trip. You can't step onto the step unless your foot is 8 inches off the ground. But you're saying to yourself, oh, but I'm going to raise my foot 10 inches. Yeah, but you can't step onto the step until your foot is on the step, which is 8 inches. So these electrons, they're very particular in what they do. So it's an all or nothing type thing. They either jump to a level or they don't jump at all. So there's a little video that I'd like for you to watch. So it's called ABC Zoom, Electrons and Photons. So go ahead and watch that on YouTube, and it's going to show you how light coming in hits an atom, and then those electrons get the energy, they absorb it, they go up to a higher energy level, and then when they come back down, they give off that energy of a certain frequency. So watch that video. Okay, did you watch it? Okay. So here's a sample question here. If an electron makes the transition from level number 2 to level number 4, is energy being absorbed or is energy being released, and how much energy? So since the electron is going up, it is absorbing energy. You can remember that because if I take this pen and it's up here and I drop it, okay, did you hear it hit something? So it releases energy as it's falling, and in order to get that pen up here, I had to put, using my mighty muscles here, I had to put energy into the pen in order to lift it. So energy goes into the electrons, they go up to a higher level, and then when they come down, they give off that energy. So since the electron is going up, it's absorbing energy. Now we go to this picture and we read off the energy that goes with those levels. And remember, when you do change, the triangle thing, when you find the change in energy, it's always final minus initial. So it was going to the 4th energy level. So that's the final energy minus the energy level 2. So we subtract those two numbers, and remember, a negative of a negative is a positive, so it turns out to be positive 2.6 electron volts. So the sign is important because the positive sign on there means it's absorbing energy. If it had been a negative number, it would have meant it's giving off energy. Okay, in our next segment, we're going to start looking at the colors given off by different kinds of elements. So I'll see you then.